In this video for section 5.1, we're going to start with a few definitions. The first is random variable. A random variable is a variable that takes on different numerical values based on the outcome of a random event. Or another way to think of it is it's the result of an experiment when that result is something that is a number. If we can list all these possible outcomes, or if there are something that can be counted, then we call it a discrete random variable. If it can take on any value between two values, it's called continuous. And continuous random variables include anything that is measured, like height or weight. If we have a list of all possible values and the probability of each occurring, that's called a probability distribution for the random variable. And we can use that to calculate the mean, which is also called the expected value. So the way that we calculate the expected value is by multiplying the value of the random variable by the probability of the random variable taking on that value. And what this represents is what we would expect to happen in the long run. So we can think of it as the average outcome if the experiment was repeated many, many times. Let's look at an example. In example 5.1, Swenson Security Sales counted the number of errors that installers made while installing home security systems. The probability of each number of errors is given in the table below. So the number of errors here is our random variable, and this is discrete because we have to have a whole number of errors. And then we have the probability of each. So to find the expected number of errors, what we do is we multiply each value of x by the corresponding value of p of x. So we're going to have 0 times 0.375, and I know that equals 0. We have 1 times 0.275, and I know that's 0.275. We have 2 times 0.125, which is 0.25, and 3 times 0.225. So basically you can think of it as just multiplying across the row. I multiply each value of x by the value of p of x in that row. Then I add all these together. And if I add them all together, I should find a value of 1.2. So that's my expected value. And what that means is that my number of errors is expected to be 1.2. Now obviously I can't have 1.2 errors, I have to have a whole number of errors, but if I were to do this many times and find the average number of errors over a large group of installations, that average number would be 1.2. Next, we're going to look at standard deviation. We can also calculate the standard deviation. The formula is a little bit more complicated, so we basically can break it down into these steps. We subtract the mean, or the expected value, from each data value. Then we square the result, and then we multiply by the probability. We add all these together, and then finally take the square root. So it's quite a few more steps, but they're mostly just little calculations. It's not super difficult, it's just a lot of little steps. So we're using our same data table here. We're going to need the expected value that we already calculated, which is 1.2. So the process is as follows. First, we start by subtracting the mean from the data value. So we're going to take each data value and subtract the mean. So we're going to do x minus e of x. So for the first data value, it's 0. Subtract 1.2, and that's negative 1.2. Our second step is to square this. So we're going to take the value that we just got and square it. Now, keep in mind, when you're squaring a negative number, it should come out to be positive. So make sure you use parentheses on your calculator around the negative number so that you get this correct. So negative 1.2 squared should be positive 1.44. Then I take this value that I just got and multiply it by the probability of that value occurring. So this is going to be 1.44 times the probability of 0 is 0.375. And if I multiply those, I get 0.540. Now, I need to repeat this process for the other three values of x. So start with subtracting the mean, 1.2, square it, and multiply by the probability. And I usually like to record it in this sort of table-like thing so that I get all my results on the right side at the end, and then I can just add them. So you should do this as well and check to make sure that you're getting the right answers. So like I said, a little bit of a tedious process, but the math is pretty straightforward here. And once I have all four of my results calculated for multiplying the squared value by the probability, then I add those four numbers together. And when I do that here, I get 1.360. And then the last step is to take the square root. So the square root of 1.36 is approximately 1.17. And so that would be my standard deviation. Make sure that you pay attention to rounding when you're doing these problems in MyLab.